this is gonna be a bit of a free-form, semi-free-form discussion. We're trying to get a little bit feedback, like, what are your concerns? What are priorities we might not have taken into account yet? Where do we want to go? I'd like to understand a little bit, your concerns around, what does it take to adopt certain of these newer things we have? And, any other questions you might have. So let's start with that because it's relatively fresh, right? Like, we had presentations on Cocos FFT and Cocos Com, right, today. And I'd like a bit to understand what would you guys need to see from the larger Cocos team to potentially adopt that, right? Like, is that something, you're gonna try out anyway, or is that something where you need to wait for a specific productivity, like maturity signal from us, and so on?
I implemented the MPI stuff in our code on the C++ side that takes views and does maybe some subset of things that Cocos Com will do. I would want to see speed, right? The other thing that I would like to have control over, for some of our stuff, it's really important the order in which we do reductions with respect to MPI, so like rank sum order or something like that. So that feature would also need to be there for us. But yeah, I think that's it.
So what would convince you, like if we had some benchmark, or if we show you that it got integrated in some of the usual suspect like ArborX, Kibana, and that they tell you that it's just as good as what they, because we have many code that did the same as you and developed their own.
I mean, even without proof that it would be faster, if it were easy to integrate, I could go and see if it is faster for us. I would be willing to do that. Perhaps also it needs to be flexible enough for me to provide our own stencils. I don't know how clear that is, but yeah, it's just some indication that it's in good working state, worth trying. I'll give it a try.
Anybody else? Any thoughts on that?
Do you think that would help if, next time they're about ready to tag, if we were throwing some sort of hackathon where they give, a small tutorial, and then we take the rest of the time to help you integrate it and see how it compares?
Okay, so like potentially something like organizing a virtual hackathon for Cocos Com, maybe a virtual hackathon for Cocos FFT or so, and see if we can bootstrap experience with it, and that way get to also get the concrete feedback what is still missing for it to work. Yeah, that sounds like a decent idea.
Yeah, I think we can see the details later, but to make it really efficient, it's probably good if you spell out your requirements ahead of time. Because some of the other code we know that would be interested in this, they had interacted in the early days of Cocos Com, so the developers already knew what they need.
Yeah. So, where is my favorite local LEMS developer? Left us. Oh. No, where? No. It's not here. Okay, yeah, we should try that with LEMS, for example. I think that would maybe be a convincing thing, hopefully. Okay. So that sounds good for that. Speaking of hackathons, right? Like, in your institutions, you know, how valuable would it be for you guys if we ran another, you know, like virtual but live tutorial round? Is that something in your institution? I mean, I assume that most of you probably don't necessarily need it, but is that something your institutions would be interested in? And or would it be more worthwhile for you guys to have in-house actual in-person trainings? Any thoughts? I mean, we've been struggling a bit with that, right? Like, our gut feeling is that doing tutorials at most conferences isn't like super useful.
Could we see who has taken one of the tutorial that we give? Raise your hand. Okay. And who has taken like the more in-depth one that we used to do with actual hackathon-ish? And so all the other, you guys just figure it out on by yourself. Like anybody who is using Cocos but has never gone to a training, neither have watched the videos.
Okay. Okay. What? Nick.
Don't say anything.
Okay, yeah, so essentially the question on our side is, right, like how valuable is it if we redo, for example, the tutorial series live, right? That was like the last time we ran that was about 6 years ago, and you know, that's a long time ago, and we did that over like 2 months, you know, every Friday, 2 hours or so. You know, is that in and of itself worthwhile for your colleagues or not, or you know, would it be much more worthwhile to do, you know, try and find people who can go around to different institutions and run in-person trainings, right? That's a question on our side we had. Any thoughts? Okay, who would absolutely prefer in-person training or thinks that their colleagues would absolutely prefer it?
Daniel, I think you want to raise your hand.
I see. Okay, sounds good. Yeah, I mean the option is certainly there. That's something I think, you know, you guys, when you you know, if you run into that, right, let us know, and we can try and find people for that. Not just here, right? Also over in Europe. I don't know how many Europeans are still here. It's certainly possible, right? But you know, we need to know. Okay. So that was on the training side, right? Going to the next thing, documentation, right? Who here felt that our documentation efforts actually have improved over the last year? Anybody? What? Did you actually look at our documentation, Axel? What? Oh, he's stealing stuff from our documentation. Okay. I see. That's fine. I mean, we are all like under Apache 2, right? Which means you can't really steal it. It's all totally legal. Okay. Do you know, who here thinks that our documentation needs significant improvement over where it is in order to be useful? Okay, that's all our team members. Anybody?
So if you have your hand up, do you have any specific aspect of it that you want? Like, you know, is there something that's specifically bad about it? Is it just in general it's lacking, or it's too complicated to understand, or there's not enough example, you know? Maybe
So we did hear many times that examples are really useful. What things that can help us is if you help, like if you chime in to help with priority, because I mean, when you know what's under the hood, there's a lot of things that suck and that we could improve, but we don't necessarily know what will be the highest payoff where we should start.
Yeah, never challenges, right, the question of what's the technical kind of level at which documentation should be written, right? We kind of aimed for something similar as CPP reference, right? Which isn't as kind of exhaustively correct as something like the ISO C++ standard, but our gut feeling was, you know, the standard document is, yes, it's great, but the number of people who really can follow what it means is more limited.
Yeah, so I agree with that. I think that even like me personally, as a Cocos developer, the thing that I found most confusing when looking at the documentation is stuff that we maybe wrote a long time ago that has like a lot of tries to use a lot of the same language as the standard, where it's like constraints on like what the type can be. But like really, I think that most people are just looking for like, how do I actually call this? You know, how do I use it? Like with examples and so on.
Anyone else among the? Yeah, okay.
I actually just have more of a general question about documentation in open source code these days. Is there any thought being given into documentation should be written so that the code is more usable by AI for code gen?
I don't think we have done anything formal yet. We are only starting to experiment with AI in the first place. I certainly had thoughts where that, you know, more AI-friendly documentation and whatnot might be useful. I'm not 100% sure what form that would take, and I don't think best practices exist yet in the wider community. I don't think we have the cycles right now to, you know, develop these best practices. But it's certainly something in the back of my mind, right? Like it's fairly clear that, you know, this kind of documentation can help AI, you know, code steering. The one big problem with that is that in some ways you need to find, is my gut feeling from the interactions I had with AI, is you have to find something which is kind of like the most compact description and still kind of like hitting all the important points, you know, you can come up with. Because if you write too much, then essentially it just loses its context window and starts forgetting what it read and starts ignoring stuff. And that's it's an interesting challenge, right? Like, in particular, if you also want the documentation to be human-friendly, right? And I'm not 100% sure that it's the same thing.
Yeah, I got
Thank
the
you.
comment for the mass libraries that it would be a good thing if we don't have equations in it. So I'm happy to remove all the equations, but then you don't know the math that I'm solving, so it's not exactly scalable. But yeah, these are things that we were told regarding AI.
Regarding the examples, one thing that I would find very helpful and that other projects do is you have the tutorials, you have the separate examples, but they're not linked to the documentation itself. So that would be, it's much easier than writing new code blocks for all functions, but if you could just reference existing codes that I could look at, that would be very helpful.
So reference the examples the code examples from the documentation, or reference the documentation from the code examples, or both ways?
You have completely working examples that show different things in one example. Okay, and from the documentation you could link to, hey, to see this in action, you could link here, click on this. This is an example you can run where you can see it in action or in context.
This is actually my point also, and we are actually doing that for Cocos kernels. Our working example is already always compiled with the in CI, and it is always checks that their example is functional, not outdated. And my concern is that the API references can be asynchronous and the actual implementation, because there is no mechanism we have So to ensure that in your API is not outdated. So I'd rather like to use here some sort of the Doxygen thingy and combine with these things which I am doing for Cocos FFT to make sure that in the API reference is always synchronous with their documentation.
I hate Doxygen, so no.
Can I? Yeah. Hey, I think just quick comment on the AI-friendly documentation. I think that goes exactly with what everyone anyway asks for. We experimented over last month quite successfully with not trying to feed it into the context window because they're too short for explaining all of Cocos, but embedding them with MCP servers that have a rack behind them that know your documentation. And it's relatively easy to do. They're like free services now. What they really need are examples, and they need short examples that have inline comments to learn. So rather have an example that does one thing well and has a couple of good online comments than having one that's complex and does everything, and just have a bunch of them. Could also be just your documented unit tests. That's what I learned quite well on. And then you don't throw these systems on your homepage, but you throw them on your Markdown RST/unit tests and let them learn from there. That works surprisingly well to suppress hallucinations and give like working examples because they're quite good in shuffling stuff together that I've seen. And there's one interface that we use that works quite well. It's called context7.com. You just throw it at your repo and let it crawl it and refresh it every month or so. Try it out. Worked really well for us to write like input files and to not hallucinate APIs from dependencies and stuff like this.
Thanks.
Yeah, to dovetail off that, an interesting thing you can do then is, you could maybe create like Slack bots or integrate that into like the documentation webpage where you can just type in a question and it tries to go find all that stuff for you. But the thing I was going to mention is on a different topic, and it's I think I now remember one time I was looking through the documentation on MD range, and I think there is a lot of stuff there, but I feel like CPP reference does a good job of enumerating all of the different possible template parameters and even some of their options. I think sometimes for me that's hard to find because, I mean, it's very nice to have defaults because then like when I'm using it, I don't have to think about it. But sometimes when I want to dig in a little deeper, having that available at the top and then all of the different options. Another one would be for like the different, it's been a long week. What do you call the memory, not constraints? Traits,
Yeah.
Yes. Memory traits. Anyway, things like that. Having those, like just a list of all the different options would be helpful. And all of the different template parameters. I think CPP reference does pretty good with that, but yeah, that would be a suggestion.
Yeah, the view is kind of a beast. I don't know if you've seen in our documentation, like we invented pseudo way of documenting things because the weird behavior where we do magic underneath the hood to force the order of parameter. There's no such thing to express this in a succinct way in C++. So we made up things where we put optional parameter between square bracket and things like this.
Yeah, one of the things that's kind of tricky about, we just have to be careful with template parameters just to like make sure that they're readable. Like, so I know you talked about CPP reference and it has a great resource for a lot of things, but like one of the things that I always get annoyed by whenever I go on CPP reference is when I look up anything in stood ranges, because like the signatures there's no way you can, like they're just incomprehensible. I literally just scroll down to the examples to see how something is used because it's like 10 template parameters and some of them are like C below, some of them are like, some weird like exposition only type. So it's just, I don't know. So we just have to be very careful and make sure that like the first thing that the user sees is very clear and that they get an idea of like what the purpose of this code element is and how they can use it to their advantage.
Yeah, I was about to say the same thing. Like, if I think about how I, for example, read CPP reference, I go to the site, and depending on if I if I already know I need to just look up the interface, I look at the interface. But most of the time, I scroll all the way down, I look at the example, I quickly check, does this do what I guess it does? And then I read the synopsis, and then I decide what do I need to read in order to get where I want to go.
Okay, so what I'm getting from it is examples.
No, what I'm saying is maybe we should think about reshuffling or like having sections that we can collapse in our documentation to make the first appearance when you like get to, let's say you click on view and you don't get like one long page that you need to scroll through, but you get a short example, maybe just the main header or whatever, and a short synopsis, and then you can click on something that says interface, and then you can see the interface. But that, like the cognitive load of consuming this documentation is easier. I guess that for people that already know what they are looking for and they just want to know how exactly does the interface look or what did you write here and there, like having one big page is fine. But for newcomers, this might just be overwhelming. Like just the amount of information, knowing what to skip is often very hard when you're new.
Okay. Good feedback from one of our core developers.
You want me to assign you?
Maybe. No. Maybe no. Okay, anything else on documentation?
Thank you. It might be helpful to have like back-end specific gotchas and back-end specific differences like collated in one place, perhaps. Especially if if like you understand one back-end more specific and you want to know, is this feature that is it available in this back-end, or this back-end behaves differently in some cases than others.
So you mean like one big overview page, or you mean within each feature like a section on differences or back-end specific behavior?
I'm not sure, just like centralized back-end specific information, I guess.
Yeah, we've been trying to make progress on this, mostly in the non-issues, but yeah, once you'll see it, you'll see that we still have a lot of work to do to document everything.
I don't know if this exists already and I'm just not aware of it, but if I would want to help contributing documentation, is there a to-do list that you have, or do you know of areas that need some love, or especially a lot of love, or how would one go about this?
What, Damien, you don't want to answer it?
Or maybe the answer is open up an issue whenever you find something that is not documented.
So there is no good place. I mean, there is existing issue open, and if you want to tackle them, they're not sorted well, and we could definitely do better with this. When you find anything and you know what the problem is, there's an edit button. Just draft something, and we can iterate on it. But yeah, we certainly could do better about compiling list of things that we know are bad.
Yeah, so I'm kind of wondering about, is there assumed conceptual knowledge about caching or SIMD or memory layouts that it might be worth having something in a glossary or illustrations for, or is that something that should be abstracted by the library? Like, I'm just thinking of like what mental model you kind of assume to use, like the framework.
So some of that stuff is essentially what the programming guide section was meant for, right? Like we have a little bit about the machine model, the abstract model we have in there. We have a little bit about like our assumptions on there, like how we map parallelism and why we map parallelism the way we map parallelism. Now, the big problem is that thing has not been updated in forever. I mean, it was, to a large degree, it was general enough that it's still applicable, right? So it's, that's why we didn't delete it simply or just not point to it anymore. But it certainly could use some some update time. Now, maybe we could use help from somebody who is a bit more in the educational field, and a bit more, has a bit more experience with like curating information, in a way which looks textbook-like and is, targeted at students and things like that, right? Where, to a large degree, the core team is all like people at the labs, right, who do software engineering, are engineers really, and not so much educators, right?
Right.
That would be something, if there's some endeavoring, young professor or already established professor with a team or whatnot who be willing to collaborate on that, that would be great.
My ears are burning.
What?
I said my ears are burning. So I guess there's also a Cocos textbook in the works. Like, is there some overlap then with the programming guide, or?
Yeah, I mean, essentially it's going to be a curated, renewed thing from the programming guide, and hopefully throughout the process we, port back some of the newer, updated thing into the programming guide.
Okay.
For projects like CocosCom, as well as those similar external libraries, it might be helpful to include links to them in the main Cocos documentation as just kind of marking these are ready for experimentation, testing, or like we want more feedback on it.
You've seen our presentation talking about developing a life cycle model. We're trying from the root, from Cocos.org to help you navigate this and communicate better on this, yeah. But work in progress.
Thank you. Something that we found very useful is Cocos Tools. And so we follow the lectures, and I feel like it's a bit outdated. There are a couple of new things that has come around. And since it's not in the documentation or well documented, I feel that there is something that is a bit missing about it, because it's really useful when you try to move on from code portability to performance portability. And it's a very cool tool.
Yeah, we are painfully aware our attempts to get very explicit funding for, a few people explicitly focused on Cocos Tools have not been super successful, or as successful as I might want them to be. It turns out there's actually the old style GitHub wiki for the Cocos Tools, which does have some information and some documentation.
Yeah, we're trying at least to bring Cocos Tools to look just like what we did in Cocos Kernel and Cocos Core, and eventually have also the documentation not in a wiki but under the same form and an edit button. So it's going to be rough at the beginning, but maybe we get to a place where it's easier to find, and it's more likely we can get contributions.
Yeah. A near-term goal for Cocos Tools is that we actually gonna start having releases there and like CI and whatnot. There's a bunch of PRs in flight right now which do some of that. So while we might not add new capabilities right now much, we do try and get it stabilized in a way, which follows a bit more the quality standards of the rest of the, primary packages. For sure.
I have a question that's not
You moved.
related to documentation. The one thing, and it's coming from two directions. One tell where I go after the motivations. One thing is coming from, we have more and more heterogeneous HPC machines or cores I compute on, and there are a lot of HPC codes that have good load balancing and that would like to use like different partitions at the same time. The most extreme one is probably if you look like in Jülich, their cluster that's like Frankenstein together, with accelerators and other things. And then otherwise we have like GPUs, CPUs naturally. And the other motivation, so heterogeneous compute. And the other thing, heterogeneous compute, is just looking at laptops, right? Where users go, where they're used to having their PyTorch loaded and saying like, run on the CPU and now run on my GPU. Just one line and it works. So one thing that I find generally missing, and it's not missing in Cocos per se, right? In all performance portability layers that we have developed like over the last decades or so, is that we have more guidance for users how to do a runtime dispatch, in the sense of that we can ship actually a binary that can at runtime take the CPU path or the GPU path in the same parallel 4. And there are some techniques in compilers like Clang and GCC, I think, have relatively sensible annotations to ship essentially fat binaries that can support AVX passes or SSE passes or other things. But that's basically users are a little bit on their own, right? How I would do this building on performance portability layer is compile module libraries and then very early on in the code switch out one SO versus another SO file. But if you could develop or think about what kind of tooling would be useful here, and then maybe how to guide this, that we can ship nice fat binaries that might support AMD and NVIDIA GPUs at the same time, it would be a better desktop experience, and it would be also allowing that people can actually think about load balancing on HPC systems about the 10% and the 90% compute.
You ask for all the simple things, right?
What do you mean explicitly about load balancing? Like, what do you want us to do? Like, we have like in Trinos, there are like stuff like Zoltan and other things that can partition a graph and load balance stuff, but like they don't. What do you actually want?
Oh yeah, no, I don't want to ask you to do my load balancing. So that's, I know how to do that for my domain stuff, but I would like to generate the kernels once I have actually load that I want to run there, that I could just very easily use the CPU path, because I say like this MPI rank is responsible for this part of the compute, and now use the CPU path. I don't want, just to have it easier to select which compute path to use. At runtime,
Yeah.
So, I mean, maybe I can chime in. So, we are currently looking at binaries. There is substantial questions with how to distribute GPU binaries in the first place. We are in close collaboration with HPSF because, like most programs here, have this problem one way or the other. Apart from that, there are some things in the design of Cocos that currently make it difficult, but we are aware of that, and we are trying to get a plan for how to support that in the future. Like, just to give you an example, like for example, if you do atomics and all of a sudden you don't know the architecture anymore, you might have a problem. And also, we don't want to disappoint users by just shipping binaries that in the end are way slower than they expect. So it's a very delicate balance, but all I wanted to say is we're trying to work on that. We do see that this is something that's a pain point for users, but we are not there yet, and there are some substantial open questions on the way.
Yeah, so I think what Axel was getting at, right, was also a question of it, like runtime from the same executable dispatching to different deciding at runtime where to run. Now, we had that question come up a bunch of times, right? And in principle, it's not completely unfeasible for us to support something like that, right? Essentially, you have your runtime dispatch execution space. You make everything unified memory, and boom, you're good to go, right? We can decide where to run. Maybe have a runtime memory space, and you just are allowed to set it at Cocos initialize, right, where you run. Now the problem with that is compile time to a degree, right? Like essentially you're doubling everything, right? What? There is some layout questions as well, right? Like that would be a problem, right? Like, I don't know for how many things it is a problem, for how many applications it's a acute problem, but it is going to be a problem, and you could, the only way you make the layout runtime is by making it runtime, which means that all your kernels are running slower, right? And in the end, the only thing you get out of that, right, is like you get one CPU backend and one GPU backend, or something like that. and for one particular architecture, right? So that's somewhat of an orthogonal problem to the binaries problem, which is like, can we ship, you know, multiple GPU architectures in the same binary, right? So, yeah, I don't know. It's an interesting question, you know, is the pain worth it that anybody would actually do that, right? And in those cases, would it be good enough to rely completely on unified memory, for example, right?
Yeah, and I think the solution would not be like in Cocos alone, right? There's clearly, what I'm asking is, can we define a way generally on these layers where with user input at the right granularity, you do a switch between architectures, right? And naturally, if you compile multiple things, the user would opt in what they actually target, right? So let's say essentially we are able to do this in other programming languages, right? So why shouldn't we? It's at the end is a really question. It would be very, very coarse, right? I'm not saying I want to have like a device function called in my kernel, by the way, now branching out to SIMD while I'm on the GPU. It's more like really parallel 4 level and above, more actually algorithm level. But can we guide users how to implement these switches without having huge boilerplate and maybe something uniform? And then, yeah, when layouts diverge, we have to, in bad cases, copy or use a less optimal layout. But it's basically, it is somewhere the interface between the users using it and how we can give some tooling to simplify this process.
I guess we could embed LLVM in our source code. And then in the main, it's like, you know, it starts with compile for this or compile for that, and then execute this as a sub-process.
I think a lot of things are fair game there, honestly. I mean, if you saw the Proteus paper, was Proteus? I think Proteus is a project, right? Paper, they did a lot of work for Raja, and they essentially do this, right? They embed their kernels so that they can legit compile them again for just the last tuning and getting the last blocking parameter out compiled. It's fine. It's maybe the biggest gun we can shoot at it, but it's one of the ways to address this.
Yeah. Okay.
I guess what I'm trying to understand in this conversation is,
sorry. Just back on the topic of the documentation. I found that the documentation would usually, when I was trying to learn about something new, was really good. I think one thing I ran into was sometimes there would be like an example, but the example would be like the simplest case of something. And I think sometimes it would be useful to have like, here's a really simple case, and here's like a more complicated case. Parallel reduce was the one that came to mind. Like there's an example of just like, here's the default, it sums all the values, there's one return value. But then having one where it's like, here's an example of a kind of complicated parallel reduce where we need like multiple return types and we're, you know.
Okay.
So it's funny you bring up parallel reduce, because I was wondering whether I would bring it up earlier when we were talking. This is daunting, this one. It's really a challenge. Like if we go into the details of what all the possible way you can use parallel reduce, it's even overwhelming for the developers. So we hear you, but this one is one of the hardest one to tackle.
Yeah, but I totally can see, you know, like having like 2 or 3 examples, you know, in like ascending order of complexity, how that can, in principle, be fairly useful.
Yeah, like it's not possible to have an example of like every possible way you can use reduce and every possible reducer.
But choosing them is
more than just the one, like just having one example of like, here is, maybe 1 or 2 more examples, and then being like, if you understand these, you can probably implement the rest on your own. But
if you tell us which one you think was missing, I know you help us choosing what you think is more interesting, that could help. I mean, the parallel reduce is just absolutely nuts, right? You can have something we detect in your functor, in your reducer. You can tag. There is a really complex rule that say which one we're going to select and how.
Yeah, there's all kinds of stuff. It's great. It's an awesome capability. Okay. Let's not go back to the, you know, let's compile for multiple things. I think that's a too complex topic. I'd like to know is you or people you know, who here downloads our tarballs as opposed to cloning a tag from GitHub? Okay, lift your hands for tarballs. Okay.
Spec
I'm
doesn't
going to
count.
ask that separately. Who here mostly installs Cocos via spec? Okay. And who here mostly does, I clone Cocos and I check out a tag? Okay. Ha! I'm not alone. He's always making fun of me.
I should have given more context before and tell you shouldn't give that to him, but yeah.
Yeah. Okay. No, it's just like, good for us to know what are common mechanisms for
Yeah,
people
but
to.
these are the most hardcore ones that stay until the end. That's not the normal user.
Yeah. That might be true, but I mean, it's also the hardcore ones who care about that something is signed, right, and would potentially download the tarball anyway.
Please don't get rid of the tarballs.
Yeah, we've been. You might have noticed we've started trying to change, and someone doesn't like this, change our instruction in the tutorial to people who don't know better to suggest they should be using the tarball, and we also started providing checksum so that you can check integrity. And I hope that more and more people are going to use it. I'm not saying you should change what you're doing, and that Christian is going to see that it's actually something we should invest time in doing.
We are investing time in doing it. Yeah. No, I just thought it's just something, it's useful to know for us what are the kind of common distribution mechanisms, right? And I was not quite sure. Okay. Luke, you have questions, things?
Oh, maybe following up on that, who here would definitely have a use for binaries if they were available? Okay, one person. Two? Perfect. Thanks.
Do you guys have any things anybody wants to bring up as their biggest concern or biggest pain point?
I mean, not a super big pain point, but I was just concerned about the removal of OpenMP just to have like a quick, CPU test, compared to GPU, especially because...
No, OpenMP CPU is not removed. It's only OpenMP offload which got removed.
Oh, okay.
No, OpenMP CPU is the primary CPU backend which is used in practice.
Forget what I said.
I have some concerns around that backend, but we need to have somebody, spend more time again on optimizing and re-optimizing it, right? We hadn't really dedicated effort on that in a few years because, we spent a lot of time on it back in the days when Trinity was around, KNL and whatnot. And since then we haven't spent tons of time on it. And I know of a couple of issues around it, around first touch, for example, with NUMA regions, where it's not optimal and we don't even quite understand why. But the OpenMP backend for sure for CPUs is currently the primary backend.
I was just confused because I saw that mentioned at one of the release briefings, and then I know all of your tutorials were OpenMP versus using the...
It's the OpenMP target offload for GPUs, which we removed again.
Okay. Thank you.
without ever reaching non-experimental status.
I think potentially leveraging work on ARM and other types of architecture might be one way for us to get back into OpenMP and one more time to go over it and look at optimizing, even though it's a different architecture. It probably will have benefits.
Absolutely right. I mean, we consider ARM architectures, for example, pretty mainstream. Things which are getting more and more deployed and with pretty high thread counts, right? And in general, OpenMP, the reason that OpenMP is in my mind gonna stay for a while the primary CPU threading backend is that it's currently the only like neutral runtime giving us a shared thread pool, right? For everything else, everybody spins up their own like stud threads or p threads or whatnot, and then they are stepping all over each other, right? And OpenMP is the only one which, you know, shares that thing. That might change, you know, in the future if we get like a, you know, standard thread pool from C++, right? We might change our recommendation there, but I mean that's, you know, C++ 26, C++ 29 land, so not anything near term, right?
Oh yeah, so Christian, since you mentioned that you are removing the OpenMP target offload, are you thinking about removing OpenACC as well in the future, or you still want to develop that backend?
No, so the OpenACC thing is actively supported by Oak Ridge right now.
Okay.
Right, there is some institutional interest in, you know, okay, actively supported with a low amount of effort, if I interpreted that correct right now. But anyway, there is an actual group which has an actual interest in that. This is something where I'm interested in the position of Riken in particular from some of the discussions around Fugaku Next. You know, there seems to be a pretty strong emphasis on OpenACC on their side, and with Cocos as kind of like a secondary mechanism. And so there is likely some benefit from having OpenACC support in Cocos, in particular to have like the interoperability of the runtimes if you have like Fortran OpenACC code combined with like C++ Cocos code. So we'll see. For now, there is no concrete plans to stop that. And you know, it's a fairly complete backend. Is there anything missing at this point? Do you know? Do you know what? It's pretty complete, right? So most apps would probably get through it, but
I think the custom registers is one of the painful one.
Yeah.
So if I can add, the reason why I asked that, as I said in my presentation, I can just use Cocos with CUDA backend and interact with Fortran OpenACC code directly, no data transfer. I don't see the point why we need to have an OpenACC backend in Cocos. Is there a particular case that...
No, there would be. Like if you were using the async queue and whatnot in OpenACC, that would be the more canonical way of synchronizing the Cocos workloads with whatever else you were doing in OpenACC.
Okay, I see. Thank you.
Yeah. Yeah. So anyway, you know, as long for OpenMP target, the big difference was there was no institution which said, I want this still, I want to invest money into this, and we were like, again, whatever. If nobody wants to maintain it, we should not have that in our site and invest CI resources and whatnot.
Yeah, and if there is interest in, for some good reason to revive it, we're not saying we wouldn't be interested. It's just that what we had was just not making any progress. It had become an actual technical debt that was weighing on development, and we just were pragmatic.
I'm going to say another stuff. I tried a few times to make it work with Cocos kernels, which is fairly close to Cocos core, and I never achieved anything that I thought was close to operational. So I don't think, you know, like we spent a lot of time and we never reached like the full potential of what we wanted to do. There's a point where you have to focus your energy where it's, you know, making progress.
And it's essentially not the first backend we removed, right? There was a QThreads backend we removed after Sandia said, you know, we are not gonna, or the QThreads team said, we are not super interested in supporting it. That's basically our stance on that. Okay.
Totally different topic, pain point. given the mission that we have in HPSF and the wish that we follow with it to make a bigger impact generally in computing with HPC technology and achievements that we have in here. One of the things, and that's a strategic point, so don't worry, there's no action item and no task
The answer is
involved.
probably
in it.
no.
One of the things that makes me a little bit sad is that if you look around, like who develops HPC software, half of us develop these on Macs, not me, but the other half. And we don't have any way to use the GPUs there. We know the technology burdens that are in there, right? And we probably don't want to go back to OpenCL and write strings. But the right thing, I think, strategically to do is to see if with HPSF, with the projects in it, with the connection to Linux Foundation, maybe with former employees that now work at Apple, we can make an in at Apple and, for example, motivate that, for example, the already existing LLVM backend for the Metal Shader language they have written could be open source so that we can address it via Circle, our existing backends, and get with that to a huge majority of the consumer market. And yeah, there are multiple ways, right? But that's the easiest potentially, and there are multiple levels.
I mean,
where only one piece needed to be open source from Apple, and we could address it.
Maybe. I get your point. I doubt that at the operational level, HPSF is gonna sway Apple in any shape or form, right? We have very good contacts to some of the key engineers in there, and there are definitely internally some key engineers who would be super stoked about making this possible, but so far they couldn't make the argument internally that it's like a good business thing to do. No, at Apple.
Yeah, the thing what I say is what we can do here is strategize how we can find arguments that convinces them. I'm very sure that we have these connections.
Also, I mean, I'm going to chime in. I don't know, given that we have multiple things that we could tackle, if that is the most pressing pain point. I mean, we get this request frequently, but if you do some like performance measurements on Apple hardware, you don't get that much benefit from the applications that would normally use Cocos. So I guess we could just have other things that are more pressing that we want to tackle than something like this.
I see your point. My point is really not to put technical burden on our side, right? My point is this is a strategic point to actually get into the consumer market and make this possible. I'm just saying I face domain scientists every day that throw away and ignore all the stack that we built here and just write their stuff in PyTorch, and then it's like PyTorch.metal, problem solved. And they are faster than running on the CPU.
No,
so
I get your
absolutely
point.
there's a case.
I think it would be of interest, as I said, we'll see.
I just don't want our lunch get eaten by PyTorch. That's my
I feel that.
I think it's.
Oh, okay. Sorry.
Oh, okay.
Vivek?
Yeah, I wanted to get this question in. So we have PyCocos. I know we've talked in some Cocos meetings about PyCocos before. I guess so. What about it is the first question, and then related note is how does Cocos take advantage of new architectural features on modern AI accelerators, tensor cores, and I think that those are the big ones, but there might be others. So, is there a plan for kind of getting that market, so to speak?
Okay. So, I mean, there was a presentation on PyCocos earlier, right? And we are still making progress. I think, it could use help with some institution which actually has a use case for it, to like help push and put some engineers on that and push that forward and mature that and get that more robust. But it's still making progress, right? On the use newer features thing, right? Like that is a problem we are recognizing. It's a problem, like we see that, for example, with NVIDIA architectures, where some of the newer capabilities they have, despite us knowing about that for a while, we did not have the driver and the resources to address that, right? We are, for example, still not exposing the memory management units which can move like memory, asynchronously from HBM to DDR. Some of it is just driven by, the institutions which are the main developers have specific architectures where there is a specific institutional driver to optimize for, right? And that has been lately mostly AMD, right? Both on our side and now at the CA side. That said, we are getting an NVIDIA machine, at LANL. I expect that means we're gonna focus a little bit more on that again. The other thing we are trying is we are in talks with various vendors to have a bit more direct engineering investment from them. So we've essentially been making the case that, if you want your hardware to give the best it can with Cocos, maybe you should help us make the backend, leverage these capabilities, right? Help us also design new features which would allow us to leverage these features if necessary. In other cases, just leverage them underneath existing APIs. I think we were heard by a bunch of them. We'll see over the next year how that engagement changes. We had pretty good contacts already, but it was mostly we have a problem, we ask them something, and they help us solve that problem, right? What I'm talking about is more like somebody in-house on their side being, somebody who on their own engagement looks out for, oh, here's this new thing. Is that leveraged by Cocos? If not, how can we leverage that in Cocos, right? And making proposals in that direction, working with us to implement that. I'm fairly hopeful that over the next year or two, we're gonna see more of that happening. It helps that the community is growing, right? That there's more institutions saying, yes, we are using Cocos, and we gain, that's the way we want to leverage things. We are trying to make the argument that in particular in the phase of AI sucking out, a lot of like resources on, also on the vendor side, that, maybe Cocos is the thing they should do, for like the productivity level between low-level things like CUDA and HIP. And when you have Python on the other side with like NumPy and PyTorch and whatnot, and instead of trying to do their own intermediate level thing, just support Cocos, right? And I think there's some people who are starting to buy that argument, and I'm hoping that we'll see some of that going forward. PyCocos, I don't know how much that is working right now. I'm not super involved in that. Cocos Tools a bit. There's a former Cocos Tools developer at AMD, for example, right? And that has been pretty decent, right? With some of the newer vendors like Next Silicon, that engagement works pretty well from the beginning. Where there's both in-house developers for the backend as well as like tool integration, being accounted for relatively early on. So, that has been working pretty well, and we're hoping to get something similar with some other vendors we are working with.
I feel that a particular pain point is contributing. It's hard to figure out how to be useful.
Okay, so first of all, this is a LANL specific thing. It would be, not the how to figure out useful, more like, it would be useful to get help with the Fortran thing. Like even just like documentation, best practices and stuff like that. I think for the community that would be great. Beyond that, it's an interesting question, right? I think if you are somebody who has, who would have like a significant fraction of their time on Cocos Core, would potentially be able to free that, right? And with significant, I mean like, 25% plus, right? Better more than that, but 25% plus, right? One starting point is potentially attending the developer meeting, the weekly one. That's where we are discussing kind of open issues and whatnot. If you are generally interested in that, right, like we can get you into the developer channel on Slack. That's where practically all our developer discussions happen, right? And then, I mean, one big problem we are struggling with is essentially code reviews, right? That's one of the, I'm not sure how helpful it would be for us to have more people submitting random improvements, right? Like we already are struggling with keeping up with what is proposed by our current developer team. And so essentially, yes, we'd like to accelerate, the total speed we are living with, but when we have more people contributing, we also need more people reviewing stuff, right? And so, saying that you have a certain fraction of your time available, right? And that's a problem, right? Like, yes, with a 10%, right, you could write a little thing, right? But when you submit it, right, and when maybe at some point you get reviews, right, and it takes forever to get around, right, because it's all asynchronous, with multi-day potentially hiccups in between, right, and that makes it all very slow, right? And again, right, the other problem is that we do need review capacity, in addition to contributing code, right?
So all of that is for, say, Cocos Core. Is that true for Cocos Com, Cocos Kernels, and FFT?
To a degree, right?
I'm going to talk for Cocos Kernels. I think we have a little bit more bandwidth. Like, we're not nearly as slammed in terms of lack of review. So there is a little bit more, bandwidth. I would see for FFT and Com where they're at. But yeah, we can take request and.
So I think let me speak for Com in particular, right? But I would guess for FFT as well. Again, one of the needs there is to have more kind of like maintainer level people, right? Who have a significant fraction of their time on it and can, also react to the kind of random contributions, right? And reviewing them and work with people, etc., right? In particular on the Com side, right? That could really use somebody who is half an FTE on that project and is, is going to be a co-maintainer or even the primary maintainer on that project, right? And drives it forward and whatnot. But that's essentially the problem between, getting something from a prototype to like a production thing is you need some people who have a significant chunk of their time on that and can focus on that and can make sure that stuff gets addressed timely and whatnot, right? And there's certainly need for that on those projects.
One other thing that we have are the working groups. So if you have a specific thing that you're interested in, I can just talk for the build and packaging one. We have people from outside that come to these meetings that are definitely under the 25% or even less of their time. That's one way. And since you guys live in the Fortran world, we have been, it's in a very, very early stage and we don't know how to integrate this because we are swamped, but we have been thinking if we want something like a working group on interoperability, which might be something that you directly care about and might be like in a slow way and like an easier way of, like with less time but more of your experience, like get into contributing.
Yeah, like getting some, you know. What?
Or even drive it.
Yeah, exactly. Getting some people together from, say, LANL, Recon, and CA, you know, as a Fortran interop group might be useful, right? Like at Oak Ridge and Sandia, we don't have much of that problem, right? As you saw, you know, like some people study just a little bit of like Fortran in order to be able to talk about some of the problems, right? But that's because we don't deal with that on a daily basis, right? So certainly, you know, I think those free institutions, if you could drive that, right, that would be pretty useful. I don't know, Bruno, how much actual Fortran do you do in your normal life?
Nothing. I learned Fortran when I started to maintain the interop, so that's all I know is what's in the tutorial. So
yeah, and that's probably not ideal for, you know, the primary person from our team being maintainer on this thing, right? And we would certainly appreciate if we could change that situation.
I just wanted to come back to usage of new architectural features and throw that a little bit back at the audience to ask what they want, in particular in like new features. Like, do they care about us having like some compression, decompression algorithms in register that we should need to provide? Or like any particular algorithms that, I don't know, Cocos kernel should provide, like more int8 support based algorithms, if there's anything like that, rather than just say like on our level, just make it better, work with the interfaces we have to make it faster.
Yeah, and in general, that is something I think some of us are struggling with. On the Cocos core level, I think the actual feature list, request list we have is fairly small, right? Like for most of my life at Sandia, I operated under the instructions, just make it work, right? That's about the specificity I got. I think Cocos kernels is in a little bit better boat. But if you have these kind of requests, right, certainly open them and talk to us about them. You know, explain a bit what you want and what your priority and your timeline for where this would be useful is. That would be good. Does anybody have anything in mind right now, or?
You might be already tired of this, but I've been trying to bug everybody here in the last couple of days about lower and mixed precision and stuff like that, which I think is getting more and more relevant. On workstation side, the lower precision performance is much higher, right, compared to like the large systems, and it will get more and more relevant.
Is that for Cocos kernels, or what is that for?
Even Cocos core, half T is experimental. There's no other smaller types. What works with what? Probably also kernels.
So the problem is bigger than just Cocos kernels in some ways. So I can write math algorithms using potentially lower types, you know, lower precision types, etc. But at the end of the day, we are hearing about these, you know, adaptable precision, like this emulation and all this kind of stuff, and we can again make it live inside Cocos kernels. But if you, as soon as you are outside of calling Cocos kernels, it all disappears. I'm thinking there's going to be a gap that's going to appear pretty quickly.
So, on the cost side, I mean, this is good to see that who's using it and what you think. Like, we're slowly trying to, you know, improve the support. Like, I mean, we were cheating with the mathematic function and no one complains, we're still doing it. Like, hearing what you see can really drive us wanting to improve.
So the thing with the half T is, right, that we need user experience. So if people tell us, you know, yes, half T, this worked for us, and we deployed it in some real app, and it does what we want, right? And it's been stable. Then it's gonna move out of experimental, right? We recently added the half T math function support, right? So like, if you call Cocos, I don't know, what is the math function? Sine or something like that?
Square
right?
root.
Or square root, with a half type, it actually will go to the correct. You see how little I'm actually writing.
I mean, you can also tell us if it sucks. I mean, that can help. We know. I mean, we hear high-level people saying we want reduced precision, but if we don't see that users are using it, like it, don't like it, it's. And you see, we have a bunch of things, and we don't prioritize it.
And we did also, as probably. In the last 2 years or so, right, we did fix, for example, our reductions that they work for, sub 32-bit things, etc. So as far as we know right now, the half types should work for in all the situations where you can also use like float or double, right, inside of Cocos, and it should be doing it in the right way at this point. So, try it out, use it, let us know if there's gaps, right? The question around tensor cores is a bit more difficult, right? We have a student working on that now, doing some exploratory work. It's an interesting question, right? Is that something which would be good enough if you had it underneath Cocos kernels, where you can call Cocos kernels, blast matrix multiply, with the correct static extents, and it goes to the intrinsic, or is it something where we should expose some more hardware close intrinsic like interface at the core level? I don't know what a good way of doing that would be, and a useful way of doing that would be, right?
I mean, I think I hear what you said regarding the workstation. So like I'm going to call them the non-data center GPUs, right? Definitely have a very different mix of where the vendors put, real estate in terms of silicon. Like it's not nearly as much FP64 as our data center GPUs. But I think this might be changing anyway. So as we get impacted, we're certainly going to react to that. But having example on places where this is already happening is also helpful for us. It drives us, I would say.
Okay, let's Yuichi weigh in, and then.
Yeah, and when contributing to Cocos itself, we are sometimes interested in the performance, and if there's an easy way to leverage all the performance regression because of our changes in easier way, and it will be very interesting for us.
I appreciate how Yuichi politely sometimes we care about performance when we contribute to Cocos. It's like most of the time we don't, but it's great.
Yeah, no, we had a discussion. I mean, Yuichi is aware of that, right? We had a discussion at the developer meeting around performance monitoring and stuff like that, and I'm hoping that we get our act together in the next.
We all agree that we should do
6 months, right? And we will have proper performance unit testing, as part on everything, right? Or at least nightly. So we should be in good shape in that, hopefully, by the next time we do this. Speaking of which, it's 5 p.m.
He's taking notes, right?
What?
That you made promises, and Jakob is taking notes, right?
If you listen carefully, I used the word hope, right? Which is a Wiesel word for saying I don't promise anything. I love it as much as anybody, but we'll see. Anyway, it's 5 p.m. I think we're closing this out. Thanks for sticking around with us. I told other people out there, in particular the spec people, how the Cocos community is so much more hardcore than the spec community. We're sticking around on the last day, even in the afternoon. I hope you all got lots out of this meeting, out of the whole conference, out of a Cocos user group meeting. And if you have further concerns, ideas, want to contribute, talk to us on Slack. You know where you find us.
Thank you.